we are going to discuss factoring the greatest common factor. And this is the first step whenever it comes to factoring a problem. And so we need to define the greatest common factor is the largest element, the largest piece that goes into every piece of a polynomial. So for instance, if we had 5y times y squared minus 2y plus 5, we would get 5y cubed minus 10y squared plus 25y. This is on the left is what we call the factored form, and on the right is what we call the product. And the greatest common factor is the piece that goes into all of the other pieces. And so we want to start with the factor, and we want to pull out a greatest common factor to get into our factored form. So let's look at some simple monomials. Suppose we have 4x and 12. If we want to know what the GCF is, well, we just look for the greatest common factor between 4 and 12, which is 4. And then we look at the variables, and we only have an x over here and no x's over there, so 4 is the only thing that goes into both. Therefore, the GCF is 4. What about 6x cubed, 12x squared, and 15x? So if we're looking for the GCF for everything, we start with our numbers. The largest number goes into 6, 12, and into 15 is 3. Because 2 works for the 6 and the 12, but it doesn't work for the 15, and the 5 only works for the 15, not for the 6 or the 12. So now we have our number. We then look at our variables, and we look at the x cubed, x squared, and x. And this is one of the times where variables come in a lot easier than numbers. Because when we have variables, we just need to find the variable that they have in common, and then we want the lowest amount of them, so that's just x to the first. So our GCF is 3x. So now that we can find a GCF, let's talk about how we find how we factor out the GCF. So let's start with 4a squared b squared minus 10ab cubed plus 18a cubed b to the 4th. So we're going to deal with each number separately. And 4 is just 2 and 2, 10 is 2 and 5, 8 is 2 and 9, which is 3 and 3. So for our numbers, we want to pick the number that they all have in common, and that's just a single 2. So our GCF is going to include a 2. We then look at each variable. So we have a squared, a, and a cubed, and that's a hidden a to the first. So we pick the small one. We pick the smallest b between b squared, b cubed, and b to the 4th, and that's b squared. And then we write a parenthesis, and we divide out 2ab squared from each piece, leaving 2a minus 5b plus 9a squared b squared. If we check our answer, there's our 4a squared b squared, our 10ab cubed, and our minus, and our positive 18a squared b to the 4th. That's an a cubed b to the 4th. There we go. And so we get back to our original answer. Now another thing to keep in mind when we're factoring is that we want the piece left behind to be in descending order, and we want the first term to be a positive. So we're going to factor out a negative 8, because that's what negative 8 and positive 16 have in common. So that's going to be a positive a. When I factor out a negative, the positive becomes a negative, and 16 divided by 8 is 2. And so we get this. And if we distribute, we get the minus 8a back and the positive 16 back. And our first term's positive. Now sometimes the piece that we have in common is just a little bit bigger than a single piece. So notice that in both of these we have the x minus 3. That's our GCF. X minus 3 is the GCF. And what it leaves behind is the 4x plus 5. And so we're undoing, in essence, a backwards horizontal multiplication method. And that's how we find the GCF.